In this video lecture, I am going to discuss one of the deadlock handling strategy, which is called as the deadlock avoidance. Deadlock avoidance can be met by following two algorithms. The first is the resource allocation graph, and the second is the banker's algorithm. So in this video, I am going to discuss about the resource allocation graph. So what is resource allocation graph? As the name suggests, it is the resource allocated to a process, and the graph which represent this is called as the resource allocation graph. And the process and resources are represented by symbol circle and rectangle in case of resource allocation graph. The symbol for resource with single instance is depicted as rectangle with a single dot, we can say, or circle inside this rectangle. So symbols for multiple instances depicted as here. Then this is the process, circle is represent a process, and the arrow from process to resource indicates that the process is requesting for a resource. And when there is an arrow from resource to process, it indicates that the resource is granted or allocated to a process. And in a resource allocation graph, all resources must be covered only once, means repetition is not allowed. Then path should start with a process and ends with a process. And if starting process is equal to the ending process in the path, then the resource allocation graph indicates that it is a deadlock. It means that if process P1 is the starting process, and if the ending process is also P1, then it forms a cycle, and then in the resource allocation graph, then it is called that a condition of deadlock has arisen. Then this is the example of a resource allocation graph, a diagram showing deadlock in a resource allocation graph. Here three processes are there, P, Q and S, and three resources are there with single instance, R1, R2 and R3. Here from process to resource arrow is there. It indicates that the process P is requesting for a resource R1, but this resource R1 is held by process Q, and this process P is also holding a resource R3, and again process Q is requesting for resource R2, but this resource R2 is held by the process S, and this S is requesting for a resource R3, but this resource R3 is held by the process P. In this way, we are seeing that the hold and wait condition is satisfied, which is one of the condition for deadlock. The process P is holding one request R3, resource R3, and it is requesting for a resource R1. Same way, process Q is holding a resource R1 and it is requesting for a resource R2, and process S is holding a resource R2 and it is requesting for a resource R3. In this way, we are also seeing that it is forming a cycle. The starting process is P and the ending process is also P. So circular condition, circle it forms. So cycle it forms. So this is the second condition for deadlock. And third is a no preemption. Means no process can forcibly release the resource. So, and final condition is that the resources are non-shareable. It means that the condition of mutual exclusion is also satisfied. So all the four conditions of deadlock are satisfied here. So we can say that this resource allocation graph shows deadlock. So here, whatever I have explained is written over here. There are three processes P, Q and S and three non-shareable resources R1, R2 and R3, which contain one instance. The condition of deadlock is present in the diagram as I have discussed. As the resources are non-shareable, process P is waiting for resource R1, which is held by the process Q, and process P is also holding one instance of resource R3. Similarly, process Q is holding a resource R1 and it is waiting for a resource R2, and this resource R2 is being held by the process S, and S process is requesting for resource R3, which is being held by the process P. So we are seeing that hold and wait condition means every process is waiting for a resource to be released by other process, and it is holding one resource itself, holding one resource, thus creating a cycle. We can say that the condition of deadlock has arisen, and arising the condition of deadlock. So if you have understood the concept and like the video, then please share and subscribe the channel, and do comment also, because if any improvement is there, then I may do. Thank you.